everyone, and welcome to another episode of 2D Twin Stick Top-Down Shooter. My name is Casanis. Guys, in the last episode, we took a look at making weapons for our goblin enemy and having those weapons swap out. So we created our enemy and we allowed that enemy to randomize itself with different weapons. In this episode, we're going to take a look at getting that enemy to move. All right, let's get started. Okay, guys, so let's take a look at a few things you're going to want to do to set up first. We are going to be using A star, the A star pathfinding system or algorithm to calculate a path between whatever's moving, in this case our enemy, and some end destination, in this case our player. So our enemy then will chase our player around based on the A star pathfinding algorithm. A star is a system that goes through and calculates the least cost path from one location to another based on a grid of some kind. And we won't go into any of the theory in this particular episode. We'll leave the theory for my students in class. If you are not in my class and you're interested in A star, you can look it up and just find out how it works. It's not really necessary to understand exactly how it works in order to be able to use it. We are going to be using a particular A star package that you can get on the Unity Asset Store. Let me just drag this over here so you can see it. We're going to be using this package. Let me click on here so we can see. We're going to be using this package right here, the A Star Pathfinding Project by Aaron Granberg. And I purchased this particular package about 10 years ago or something like that. I forget exactly when I purchased it. There has been constant updates to this package. When I bought it, it was $100. It's still $100, but he offers a free version to use in your projects. And I really recommend you download it and you check it out. We're going to be exploring it today. I use this in a lot of my projects. You could go ahead and write your own A star if you want to, but this person's done all the work to get it done and they've updated it. It does so many amazing things. Check out the videos. I promise you, if you pick up this package, you will not be disappointed. I purchased it, like I said, for $100, but there is a free version. You can go to Aaron's site and you can download the free version right off of their site. Later on, I really recommend you purchase it. If you find that you like it and you thought it was helpful, I really recommend that you purchase it. I use it for so many of my projects now. Okay, so let's take a look at a few things that I did in order to get this thing working properly. I built this kind of play space. I decided how big this play space was going to be. This is the area that my player can run around in. This is the area that my enemy will chase my player in. You can see a grid here right now, but just ignore that. We'll get to that in a second. I put in borders just to make sure they couldn't cross this, and these borders are also going to define the grid that I'll be using for A star later on. I'm going to keep the A star movement within this gridded area. Okay, once you have downloaded the package, the Pathfinding Project package, and you've installed it into your own project, it's going to come with a bunch of different things. It's going to come with a whole bunch of different example scenes. You can look at them. I think there's 12 or something like that in what I have here, and then the pro version is 12 or 15 or something crazy like that. All different ideas for all different things. In this particular case, we're obviously going to be using a simple version for 2D, and it works wonderfully for 2D. Okay, so let's take a look at how we're going to go about setting up A star to work with our project. The first thing you're going to do is you're going to create yourself a game object, an empty game object, and you're going to name it A star. And you can set the transform to 0, reset your transform so it's in the middle. It doesn't really matter. With this particular version, you can actually move around where your grid is and everything works great. After you've got yourself this empty game object, you're going to find the component Pathfinder that is associated with A star. Add Pathfinder to this object, and we're going to make a few adjustments. Whenever you first add the Pathfinder component, it has the option of adding a grid graph or adding a new graph. We're just going to use a grid graph. A grid graph is going to allow us to create an area that has a grid associated with it that we're going to move across. You're going to make a couple of quick changes to it. First thing you're going to do is you're going to set it up so that it's 2D, and you're going to choose grid as your shape option. There's a bunch of different options in here. We're going to be using grid as our shape. That's going to give us nice little squares here that we can use to move around. Set the 2D option so that it knows it's within 2D space. We don't have to worry about 3D. There's no kind of up and down associated with it. Below that is this aligned to tile map. In my particular case, I did align it to a tile map because this is a tile map that I added in. You don't have to. You can just leave it blank. You don't have to align it to anything at all. It'll just automatically align along the proper axes like this. If your play space is rotated and you have to rotate this object, then you could do that. But otherwise, don't worry about it. These are the important things you're going to have to change right now. These next three are kind of the important ones. The width and the depth are going to define, obviously, the width and the depth of your grid. In my case, mine is set to 51 and 35. Uh, that's going to be up to you to change as you wish. Obviously, your play space is going to change based on the game that you're making. Below that, you're going to see node size, and mine it comes in as default set to 1. It's a pretty good default value. You can change it however you wish, however. The larger the node size, the fewer nodes you have within this area. And the fewer nodes you have in that area, the lower the cost of the calculation. Basically, the way A star works is it examines each square, it determines the cost of moving to each individual grid space, and then based on the lowest cost grid space, it's going to then create a path based on each consecutive grid space based on the lowest cost. So the fewer nodes you have to traverse, the fewer calculations you'll have to do, and the faster the calculations will occur, obviously. The more nodes you have, so the smaller your node space, the benefit of the smaller node is you have more nodes, and the more nodes you have, then the more accurate the movement's going to be. If you have fewer nodes, it's going to move in a less accurate manner. The more nodes, the more calculations that are going to occur, but the more accurate the movement is going to be. Okay, so you can play around with the node size value. I left mine as default for this particular example. Okay, is there anything else I had to change inside of this? I don't think so. So there's nothing else we had to add actually or change just to get everything moving here. Nothing else we had to actually change within the grid graph. Once we set that up, we can leave it and the grid will be generated. I think if you click on the no, I'm sorry. I lied to you. I lied to you all. You do have to set it up to use 2D physics. If you don't set up to use 2D physics, if I turn this off, for example, this is how it comes in default. And by default, it's for 3D. Click on the 2D, and it's going to change it so that instead of using depth and height, instead of using height, it's only going to be using a 2D surface, and it's going to be only using the physics 2D system. You don't have to change anything else in here besides this obstacle layer. So what's this obstacle layer? If you don't have obstacles that you're going around, if you don't have parts of your map that you can't traverse, then there's actually no reason to actually use A star or any other pathfinding system. You can just have the enemies move directly towards your player. There's nothing in their way. They can move right through everything and they can just move directly towards your player to attack. The reason why we want to add in something like this, the AI pathfinding system algorithm, is to ensure that our enemies can move along a path that wraps around obstacles in untraversable areas within the game. So the obstacle layer defines the nodes that aren't traversable. That's what this is for. It defines the nodes that are not traversable. In my case, what I've done is I've added in a brand new layer called obstacle. That's what it's called right here. That's my layer mask. If I go into my level hazards here as an example, and I take a look at one of my turrets, I have I'm going to place, I haven't done it yet. I'm going to place just this guy, no. I'm going to place my turret inside of the obstacle layer. I thought I did this, but I guess I only did it for one. Cool, cool. So obstacle. Just not the children. Leave the children alone. Okay, so I've placed all these things in the obstacle layer, and now my enemy, as it moves around the space, it will ignore the spaces where there's an obstacle. It'll go around there, so the calculations are allowed to go around the space. Okay, so create your obstacle layer. Then once you've created that particular obstacle layer, make sure that your obstacles are in that particular layer. And afterwards, inside of your A star, set up your obstacle layer to reflect that. Okay, that's took a long time to say that. Just it'll avoid those things. Okay, let's take a look at the changes we have to make to the enemy in order to have this work. If we take a look at our goblin base, let me just turn something off here so we're not taking a look at it right now. I'm going to turn off this enemy movement. There are a number of different components you have to add into whatever object you want to get moving. There's actually 3 components that you have to have. The first component is the seeker. The second component is the AI path, 2D, 3D. And there's other options as well, but in this particular case, these are the ones we're using. And the third is the AI destination setter. So the seeker, you don't have to touch at all. Once you've added, I've added to the base of my goblin here where my rigid body and everything's located. I added the seeker there. You don't have to touch the seeker at all. It's ready to go. Later on, if there's some things you might want to change in here, but to get the basics working, just leave the seeker directly as it is. Same thing with the AI destination setter. We have to put in the destination where we want this object to move to. In our case, we are chasing our player, so the target is going to be the player base. I just dragged it and dropped it in here. Now, later on, we're going to want to set this up maybe so it's dynamic. If there are multiple players in the scene, if you've made like a local multiplayer, this target should be set dynamically. So if a player comes too close, it changes its target, etc. You might want to do something like that. Or later on, if you're setting up your enemies so that they are, they can be aggroed, so they're not moving until you get too close. And when you get too close, then the target gets set. You'll want to set this dynamically. We're not going to look at that today. For now, we're just going to get everything up and running and moving. Maybe we'll look at it in a future episode. We will talk about coding and the use of these components at the end of this episode, however. So there's not a lot of changes to the AI destination or to the seeker. The changes kind of occur here in the AI path 2D and 3D. With the AI path 2D, 3D, there's a number of things we're going to change. The shape, under shape, we have radius and height. We can ignore the height. I don't think the height does anything when we're talking about a 2D system like this. I think it's only the radius that changes. Let me zoom in here so you can see. If we see this kind of yellowish square, excuse me, yellowish circle that's around this, that's the radius. And that kind of defines the area of calculation or interaction. I have it set to 1. You can set yours up so it's whatever size you want for your particular moving object. Let's see what else we had to change in here. We can, like I said, ignore the height. Down here, we have a couple of options in movement. We have the can move option. It's going to be set to true. Leave it on. So as long as can move is true, then the object can move. If can move is false, it can't. So later on, if you're thinking like, oh, I don't want my enemies to start off moving right away. I want them to wait until the player gets super close and then they're going to jump out of the whatever and attack. Then you can adjust can move and you can do all that through code is dynamically set. Below that is max speed. The max speed is the maximum speed that will be achieved by the moving object. That's what it is. These are values you'll play around with. I've got a value of 3, so it can't quite catch up to my player. Maybe you want something different. Obviously, it's going to change based on the size of your asset and everything else. So you'll adjust your can move. Sorry, you'll adjust your max speed to whatever it is you want. This is a big one right here. The orientation, the y-axis forward. By default, it comes in with z-axis forward. That's for 3D games. For 2D games, you want to make sure that you have the y-axis forward. If you don't have that set, it won't move. All right, so that's something you're going to set right away. What else? Oh, this down here is pretty important here. The end reach distance and the slowdown distance. By default, I think the end reach distance is very small. It comes in as 0.2, I think. And that's basically the distance that it travels until it thinks it's at the end. So once this enemy is 3 units away from its destination, it will consider it the fact that it's reached its endpoint. Like I said, it comes in really, really small. If it's really, really small, they'll overlap the player. So I adjusted this value so it gets close to the player, close enough that it's still going to swing their sword. The goblins will swing their swords and still hit the player, but it won't overlap. This is again something else that we might want to like change dynamically later on. In fact, I'll have to explore that later on for ranged enemies. I have my goblins set up so they can either be melee enemies or bow wielding goblins for ranged weapons. I don't need my ranged goblins to run all the way up to my player. They can stay back a little ways. So I would probably change the end reach distance to whatever, like 15 or 20 or whatever it is, some value. I have to obviously measure it and check some value so that is the maximum distance that it's going to be away. If it gets further away than that distance, then it'll start running again. So if I set it to like 15 or 20 for my ranged enemies, they will run within 15 or 20 units of the character, start to attack, and stay that distance away. If the character starts to run away further, then it'll chase, but otherwise it'll stay that distance away. It won't retreat, so if you move closer than this value, so if I move closer than the value of 3, for example, then the enemy won't like try and maintain a distance of 3, as long as it's within between 0 and 3, it's considered to have reached its destination. And I think, yeah, that's I think all that we had to do, just those couple of changes, and that's enough to get our character moving. So let's take a look. If I hit play here, then we'll see exactly what happens when the enemy starts to move. Okay, pick this up. All right, so you can see right away my enemy is chasing after me. All right, if it gets close enough, it still swings. I can still shoot it. Let's see if I can hit it. I can still shoot it. It still takes damage. All right, it'll go around. See how it went around that obstacle right there? If I let it get close to me, it'll swing. I'm going to die if it hits me. There we go. So it'll still swing, and then as soon as I start moving, it starts to move again. There we go. Hits me and starts moving again. Oh, it killed me. Okay, bad at my own game. All right, guys. So that's it. Our enemy is already moving. It's already chasing. It's doing exactly what we want it to do. There's just one more thing I want to demonstrate to you in this episode, and that is accessing all of the different components through code. Really, really straightforward. All I'm going to do, I'm going to go back to my enemy goblin base here. I am going to come down here and turn on this thing that I turned off, this enemy movement controller. And let's take a look at it. Let me just drag it over here. Enemy movement controller. Here it is. So in the enemy movement controller, what I want to happen is if the enemy's moving, I want an animation to play. That's it. I want my run animation to play. Okay. So actually, let's move this out of the way for 1 second, and let's take a look at our animator. The animator is super, super simple. I've got a goblin idle, which has nothing in it. It's just standing there. And then I have a goblin run, which is very similar to the run that the player does. It bobs back and forth. I traverse from one state to the next. If is moving is true, I go to the run, and if is moving is false, then I stop running. Okay, so let's drag this back over here for a second and take a look at the code. The code is super straightforward. If you want to access any of the functionality within the pathfinding libraries, then you using pathfinding. That's it. In the code itself, I have a reference to my animator. I have a reference to my AI path component. In the start, I find my AI path and I find my animator. In my fixed update, all I do is I set is moving to the magnitude of the velocity. Well, okay, so what I'm doing here is I'm checking out the AI path, the velocity that this particular object is moving at. I take a look at that velocity. Instead of looking at either the x or y values, I take a look at the magnitude. If the magnitude is greater than 0, that means a vector has a direction and a magnitude associated with it. So that magnitude tells me if I'm going more than 0. If I'm greater than 0, then this will return true, and I return is moving true to the set bool, and we move from one state to the next. If velocity is equal to 0, because I'm looking at the absolute value. So if the value is equal to 0, I'm not moving. I send a value of false, and I stop playing the animation. That's it. So it's like 3 lines of code in here. I just wanted to demonstrate to you that you had to use pathfinding. That's all I was really trying to show in here. But again, if I hit play with that now turned on, you'll see that now my little goblin guy will chase me, and he'll run along like that. I'm gonna shoot him with my bow. Get revenge for the last time. See if he gets me. We tried. Oh, one more. Are you going to get me? Not this time. Man, I'm really bad at my own game. Okay, kill me. There, dead. All right, guys. So that's it. You can see that as the goblin moved around, if it was moving, it would animate. If it was not moving, it wouldn't animate anymore. All right, guys. Well, that's it. That's all I wanted to show you. It is that easy to get your enemies up and chasing your player. You could save this goblin out if I wanted to. I could add 10 of these goblins in, and they would all work exactly the same way. All right, guys, I hope you enjoyed it. If you did, let me know down below with a thumbs up. And if you didn't, thumbs down is perfectly fine. I'm making these courses, really, I'm making these different videos to make sure that my students have something to fall back on if they miss something in class. I'm not covering everything that I'm doing in class. Obviously, I'm not covering how A-Star works or anything like that in this particular video, just the technical side of things. So, guys, I hope you are enjoying it. I hope you're getting something out of it if you're actually not in my class. All right. Thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.